Welcome to this presentation on Freeze and Reveal, Exposing Modality Bias in Vision Language Models. This research was conducted by Vivek Hruday Kavari et al. And published and submitted on 10th August 2025. Today, we will explore the key findings and contributions of this important work. Let's begin by understanding the problem this research addresses. Vision language models, or VLMs, are really good at understanding the world by combining what they see in images with what they read in text. Think of them as artificial intelligences that can both look and read, and then connect the dots. However, these models can sometimes pick up biases from the data they are trained on. One common problem is gender bias. This means the VLM might make unfair or inaccurate assumptions about people based on their gender. To understand where the gender bias comes from, we use two main techniques to try and reduce it. The first is called counterfactual data augmentation, or CDA. This involves creating slightly altered versions of the training data to help the model learn to ignore gender when it is not relevant. Imagine changing the words in a sentence to remove gendered pronouns. The second technique uses something called task vectors. We tested our debiasing techniques on a special dataset we created called VisualGender, which is specifically designed to measure gender bias in VLMs. We found that CDA, which focuses on changing the training data, was effective at reducing the gender gap in the VLM. Our experiments showed that using the CDA technique significantly reduced the gender bias in the model is trained on. Our findings suggest that the images and text that VLMs learn from play a big role in creating gender biases. By using techniques like CDA, we can reduce the amount of bias that the model exhibits. This is important because biased models can perpetuate harmful stereotypes and make unfair decisions. While our debiasing methods are effective, there is still work to be done. It is not enough to simply fix the problem after the model is trained. In conclusion, our research showed that vision language models can inherit gender biases from their training data, particularly from the visual and textual content. We were able to reduce this bias by using data augmentation and task vector methods. Our novel DOS metric allowed us to efficiently evaluate and mitigate gender bias, paving the way for fairer and more equitable AI systems.